నాన్న ఇదేంటి నాన్న ఇది? ఆ? Which array it is? This is fixed array. So this is how we will declare fixed array. See, in the brackets, we are initially at the compilation time only, we are giving values. How many memory locations we want to store. So iterative variable always we will take either I, J, K like this. Those are scalar variables. We will take as iterative variables in general for single dimension, two dimension, three dimension. So I equal to initialize it to 0. These are of data type int. Now here see initial begin repeat 10 array of I equal to I plus plus. We are incrementing. Initial I value is 0, so it will come 0. Okay. So here in dollar display, what will display ma? 0 to 9, isn't it?
Yes, sir.
Because only 10 iterations are there. See 0 to 9. See, we gave repeat 10, so it is displaying from 0 to 9. What will happen if I give 11? 11th element, what will happen?
0 to 10 will print here.
0 to 10. Let us see what will happen. It is taken only 0 to 9 only again. At least, can you guess now why? Because we gave array size. Initially, array size we gave 10 only. For example, if we give here 7, so it will go to 0 to 6 only. Getting?
Okay.
We are giving only that many locations. Okay. Now what we will do is this repeat. This is also like a loop. The same thing we can do with for loop. You know for loop, right? Already. Here, what it will display here? Hello. In this for loop, in this array we are displaying here. So what it will display here? Zero to 6, isn't it? Let's see. But we kept it in initial block. So how it will react? We'll see. See, still 0 to 6 only. So here what will happen? Hello? Am I audible?
Yes, sir.
Here what will happen? You tell me now.
You give 0 there, no, sir.
What?
0.
What 0?
I will 0 there. Here print 0 to 9.
0 to 9. Here we fixed only 7 locations, Nama, not 10.
There, no, sir.
It will do
Okay, 0 to 6 value. 0 to 6, sir.
0 to
0 to
6.
6.
Okay, that is index. What is its array value? What it will display here? 7 5s. Here we are fixing the value, right? For each array of j, we are assigning value 5 to array. See, 7 times 5 will come. See, getting? Because for each of j, index will be 0 to 6 only. 7 iterate 7 locations. But each array value will be 5. Here we are giving assigning. So it will. Now we will see first class. Okay. That class handle we are creating in a module. Module is a static component. Class is a dynamic component. And f equal to new. This new always creates an object, or we call it as an instance, or we will call it as an object or an instance. In this handle, we are creating memory. In that memory only, these variables are present. So whatever we will play with these variables, whatever operations we will do, that will store in this memory only. See how much memory it can take. Initially, these are range. Okay. See, it can take entire heap also based on these operations. Whatever heap is there, that it can take. So after this is hash 1 means 1 nanosecond or any time scale time units. After 1 nanoseconds, we are displaying. So initially, we are displaying value of C. To access any value of class, we will use dot operator. F dot handle. This is called handle. Handle dot methods. Data 1, data 2. So initially, we will get what values we will get. Initial reg values are what? X, right? So we will get X. Or do we get X or 0? See, X. If we initialize values, okay? For example, if you initialize reg2 equal to 2, then it will display 2. X2. X is reg and 2. See? Here all you need to understand, this is just dynamic component called as class and its properties. We will call this is our variable, simply speaking. But sometimes we will call properties also. Properties of the class. And uh, type of a type, reg type. See, 2 down to 0 means 3 bit. This is 3 bit. For example, if I give here 3 bit means 0 to 7, right? If I give 14 here, what will happen? Or else if I give C, then what will happen?
No.
Okay, I'll give 1 0. Why it is displaying as 2? Because it is taken this data as binary by default. So take D. Let's see. Which means I'm telling like it is a decimal. Still it is taken as 2 only. Though I mentioned it is a decimal value. Why? Okay, you go through once. We will discuss that in next class. You go through once. See, here we are giving D means decimal value. For example, if you give here H, F. F means 15, right? So if we give F, then what it will, 3 it will give, I think. Oh, are you getting now? Why it is taking? See, hexadecimal F means all ones, right? So 3 ones it is taking. That's it.
Yes. sir, I understand.
What?
H value. Okay, sir, I will understand that. But
See, for example, see my, if you don't mention anything, okay? So any decimal value, for example, if you give 9, then which value you will get here? Suppose you will get here 9, right? See, if I am giving some value to the variable, but it should give the same value, right? I am giving here 2, data 2. I am getting 2. I'm the data I am giving 9. Will it come 9?
no, sir.
Which value it will come? Tell me. 1. Why? If we give 8 here, then you will get 0. See, you are getting 0 here. Data. If you give 7 here, what you will get? 7. Exactly 7 will get. See, 7. See, 3-bit means 0 to 7, any value it will give. Beyond that value, it will truncate to last LSB 3 digits, and that value only it will retain. That's why for 8, 1000, so you are getting 0, all 3 digits. 9 means 001, so it is getting 1. Likewise. This is it. Simple. There is a class, dynamic entity. You need to understand from like this only. There is one class, or simply 2 variables are there. Data, data 2. I'm giving some values to it, hardwired values. Okay? Or we can generate. Any generated values also not an issue. Then I'm accessing those values outside of the class. Module is not a class. End class here. Outside of the class means after end class I'm in these values, data and data 2 values I'm accessing in a module. That is called outside of the class. Okay, in this outside of the class, I'm creating memory. For example, if I don't create memory, then what will happen? It will return null pointer, right? It means there is no memory. But this tool is giving an error. Generally, it's supposed to point to the null pointer, which means there is no memory. Likewise, it should tell. That's what this error also means. We need to create a memory first. To create a memory, we need to use these brackets. If we use the square bracket, then it is a dynamic memory array declaration. New of this square brackets. Okay, we'll go to next. See here, same variable. I'll go incremental manner. See here, for that variables, I am assigning uh, I'm assigning data in a module which is outside of the class. So we will get the same value 2. These two meaning same only, right? 2. This is 3 tick B. This is 2 tick B. Same. It means same. 2 2 you will get. Fatal error. Yeah, fatal error we got because we made it to null pointer. So I'm commenting this, so you'll get some simulators will show null pointer. See, 2 2 you are getting value in output. Here I am assigning, this is called memory deallocation, which means we are allocating memory means creating memory. We are deallocating memory means we are destroying the memory. Okay. This is the static module only. We are taking 4-bit inputs, 5-bit output, and we are declaring a clock. This is how initialization of a clock. This is declaring a clock. So 10 nanoseconds, which means 100 megahertz clock. Task add. We are using one function task add y equal to a plus b n task. So task stimulus AB. In this task, we are giving AB values and we are calling add function. After 10 nanoseconds, we are giving some more values. We are calling add function. So it will call this and it will execute this AB and it will assign to Y. So okay, okay. So we will get three values now. Y equal to 4, 11. 11 means AB. 4B, 15 F. There is an error. Initialization fail. Why so? AB. Now we are calling Steam clock. Fatal error. Steam clock. Module not found. Tim clock. Yeah, I made small mistake. Actually, I'm using Steam clock instead of Steam AB. So I'll comment this. Now it will work. Yeah, now it will work. Okay, 4, 11, 15. Are you getting? See, it's simply adding two values. See here, 1 plus 3, 4, 5 plus 6, 5 plus 5 plus 6, 11, 7. So here, this is called basic addition. Here, for every clock it is doing. Here, that's why we given like 10 nanosecond. Okay. For example, if we give here 9 nanoseconds, then what will happen? Same output, right? It doesn't matter.
Okay.
See, 0 nanoseconds, still it is executing. It doesn't require any time to do it. Here also you give 0, sorry, 0, 0. All are 0 nanoseconds. See, we are getting output by 4. Addition we are doing. Same. 0, 0 simulation time only it will have. These are all things gonna happen in additions basically. But if we want to see it in a clock, see, the problem will arise if we go for a clock. Did we? Okay. Wait, I need to check that syntax once. Okay, we'll check once. See, I'm writing these so that we can see in waveform. If we want to see in waveform, then we need to write these two lines. We'll see what will happen. Okay, okay. So I'm taking this now. See here, clock is generating, but AB values are assigning at 0 time, and the result also we are getting F only one value. That what we are doing is we are assigning at 0 time, so it is overriding the values. So to avoid that, we will give time. Here I'll give time. See, I'm giving 0 nanosecond, 1 nanosecond, 2 nanosecond. Now, see here, in 0 nanosecond, BF, two values are coming. Okay, I'll give 1, 2, 3, for example. One hash means that is pound symbol, which means the time delay it represents. 1 nanosecond, 2 nanosecond, 3 nanosecond. Let us see. See here, 1 plus 3, 4, 5 plus 6, 11. That is representing it. Here, radix, it is in a hexadecimal. I'll make it to decimal so that you can understand. 11. So 8 plus 7, 15. Are you getting?
Okay.
But it's best practice to execute at the clock edge. Okay. Here it value is 5 nanosecond. Here it's 10 nanosecond. So we will give it the 10 nanosecond now. Ten, 20, 30.